Hi guys, and welcome to this video on our log transform. I'm Maffs Guru, otherwise known as Darren. Actually, that's how I'm known. I suppose it would be otherwise known. Anyway, that whole new discussion. Thank you very much for joining. This is the third video in our data transforms for the Further Maths course. Thanks for coming along. If you haven't already done so, do me the honor, please, of subscribing by clicking that little doohickey in the corner. Your support is greatly appreciated. Leave a message below if you can do, and tell your friends about this channel. I've got about 1,200 subscribers, which is awesome. I think most of those are my family. Everyone else is out there watching cat videos. Now, the log transform. In our previous video, we have looked at the x squared transform, which is also equally supported by the y squared transform. We're going to look at log transforms now and probably deal with one example, but it applies to both a log x and a log y transform. Now, in previous lessons, we have looked at this wonderful circle of transformations provided by Cambridge Essentials textbook, the Cambridge Further Maths textbook. And so we can see that data curves in one of four ways, and we're trying to turn that linear. So we have a log x, a log y, and a log x. That's interesting, and a log y. So again, there are three different sort of formats of graph where we can do log transforms. What does a log transform do? Well, if you go back to a previous video, then we knew that, for example, the log base 10 of 1,000 came out to be 3. The log base 10 of 100 was 2. The log base 10 of 10 was equal to 1. And so if you remember from that previous lesson, as these numbers got progressively larger and larger and larger, we sort of were able to scale them back and make them smaller, sort of redefine the scale as it was. Hold on a moment, that's what we're doing here. I know, I get way too excited about this stuff. Sorry guys. So let's have a look at some sort of practice data and see why this is happening. So there we go, we've got a nice curve there, which we know from our circle of transformations a moment ago is ideal to transform using a log x transform. Now at this moment in time, there is my x value and there's my y value. And if you've watched our previous video or my previous video, then you know that we've got to be also very careful what these be changed to. So we are saying, well, a log turns big values into small values. And what that would suggest in this situation is, that's right, points at the far end are going to move in and in and in. So what we would suggest was this point here, which is really, really wide away, will probably move all the way back here. Now, although that doesn't look necessarily straight, you've got to remember my y values are not the ones that are changing. This value here may move to here, and here, and here, and here, and here, and here. And what do we notice? I know I've constrained it that way, that actually these will come into a nice straight line. I've effectively just squidged them in. And yes, what we would need to make sure in that situation is that this now became y, and this here would become log of x. That would then give me a nice sort of linear line. Now again, remember from previous videos, we are given a number of transforms. If we go back to this circle of transforms here, we are given a number of transforms that could linearize the data, and we are looking to choose the one that will give the best linear approximation. Now, how do you know that? Sadly guys, you try all three, or if you are over here in Australia, you are probably advised to try all six. How do you do that? Well, ultimately, once you've got the data in your calculator, you're just adding extra columns. This will come in a later video because I'm going to go through maybe a practice sack. But the point of it is you are looking for the best linear. And in this situation, a log x may well turn out to be linear. Now again, as I've said in the previous lesson, and I'm going to keep going over and over this, if you remember, the equation of a straight line, which is what we're trying to do, turns this into y equals mx plus c format. That is the stuff we've taught you in year 9 and year 10, but obviously for further maths now, that becomes y equals a plus bx, where the value of a is our intercept and the value of b is our gradient. We know this, but now, as I've said previously, we cannot label our axes x and y if we are changing them, and we are changing them. For this particular instance that we're dealing with, we are keeping our y values the same, but this will now become log x, and in which case I would not write that as x. As I go on to say here, and all these notes are downloadable at mathsguru.com, what do we notice? I've got log x there. So this is y equals a plus bx, which has become log x because my axes are log x. I sound like a broken record, and I probably am a bit of a broken record because unfortunately people make so many mistakes. And Cambridge have very kindly given us an example of how this actually works with some real data. What do we notice? GDP is our explanatory variable, lifespan in years is our response variable, and yes, we see that this is in fact curving. If you want to go back and have a look at our circle of transformations, and what you'll notice is, yes, this is ripe for using a log x transform. And so what do we notice? Yes, our bottom, our explanatory variable there is now called log GDP, and my y values stay exactly the same. If we look at this first point here, we notice that it's about 68 high. Do I notice this point here? It's about 68 high, exactly the same. But what's happened is it seems to have moved further away from the axis there, okay? So, further away, why has it done that? Remember, small log values get bigger, large log values get smaller. More on that in a totally different video. But we can see here that whereas in the previous video where the dots all seem to be beautifully straight, we notice that actually they're all a little bit over the place, but the chances are way more linear. Okay, so we've now been able to do our analysis, and what we've come up with is now our formula that says, well, once again, remember it's y is equal to a plus bx. So reading off the data, having put this data into my calculator, my y is lifespan, because that's my vertical. My A is 53.4 because I imagine somewhere along the lines we'll have found 53.4. Now, a lot of people go, well, hold on a moment, that value isn't 53.4. No, it isn't, and don't get tricked on this either. What do graphs always or usually always start with? 0. Congratulations. So our value here of our intercept is when log GDP is equal to 0. Do we notice here that our graph does not start at 0? Congratulations. So we cannot read this value off here as our intercept. You would have to draw that graph going further back, 2.5, 2, 1.51, 0.5, and 0. And when you extrapolate that graph back, long word, back, I reckon then we would end up with our intercept as 54.3. Going on, yes, here is our gradient plus 5.59. Why is it positive? Yes, because my line seems to be sloping up, which has a positive gradient, and probably the most important part there is that it says log GDP. It does not say X. All right, so as I've done in a previous video, I've done all the screenshots here using my Casio ClassPad already. I love the Casio ClassPad. If you are using the TI Inspire, I used that for many, many years as well, but I think the Casio's got a bit of an edge on it at the moment. If you are using TI Inspire, I will do videos on this a lot later on, so don't worry, but the idea is pretty much the same. So, using an example extracted with permission from the Cambridge Further Maths Units 3 and 4 textbook, the table shows the lifespan in years and GDP in dollars of 12 people in 12 countries. In 12 countries. The association is nonlinear. Thank you. That's an exam or a question basically saying you're going to have to data transform. I have highlighted there, use the log x transformation. Exam questions will generally tell you which transform to use because it's going to be quicker. There's not a lot of time in exams for you to be doing lots and lots of these transformations. But in your SAC, you will have to probably choose, or exams or longer projects, you will have to choose the transform that is the most relevant. And you need to do all 6 transforms on the data that you're given. Yes, I know. Hold on a moment. Breathe. Get yourself up off the floor. That calculator is there to do all the hard work for you. I know not all of them are relevant, but I also know that some SACs have been set where you are asked, you are expected to do all 6 and then check the value of R or R squared. Now we've already done correlation coefficient and coefficient of determination. We know what R and R squared show, so you would be looking at choosing the transform that gave the highest value of R or R squared, but that's a little bit outside of this. So, what does it ask me to do? Linearize the data and fit a regression line to the transformed data with GDP as the explanatory variable. Thank you very much for telling me that. That's useful to know. Write its equation in terms of the variables lifespan and GDP. Correct to 3 significant figures and use the equation to predict the lifespan of country with a GDP of $20,000. Right, here we go. Firstly, notice what transform they've told us to use, and we've got that. So zooming in, I was about to say scrolling in. So the first thing I've done is I've put all of my data in, and what do you notice? I've got titles there of lifespan. I've got a title there of GDP, and I've got one set up for log GDP, and I've entered all of my data in. Yeah, the first thing I wanted to do was check that we actually isn't linear. I suppose that's the first thing we should do. And what did I do? Oh yes, I brought up my stats graphs, and I said that for graph 1, make sure it's switched on. I would very much like to do a scatter and just show me what the current graph is. They told you the explanatory variable was the GDP. And so the lifespan would have to be our response variable. When I hit set, what came up? Yes, ladies and gentlemen, this graph here, which very much does not look like it is linear in any way, shape or form. So, okay, we've done that. We've looked at it. It's not linear. They've told us to do a log GDP. How do I do a log GDP? Well, if you remember, and this is fairly repetitive, write this in your summary book. Do what you need to do. Annotate these screens, whatever you need to do. If you remember, you click in here, wait for that to change to cal equals, and then type, literally type using the keyboard, log, open bracket, GDP. Now again, because I chose to use capital letters there of GDP, I have to make sure that I use the same capital letters there. Don't leave that as list 2 and then try and type that in there as log GDP. Your calculator will go nuts. Sorry about that. Don't quite know what happened there. Hit a button on my screen and apparently it's trying to connect to something completely different. So having done that, I obviously now want to plot that. I haven't done the screens again, but again, you would now open that little button there and change now your horizontal, your list X to log GDP. And what do we notice? Well, it seems a lot more linear. Yes, it seems a lot more linear than it was. And so I go and do my linear calculation. Again, I'm not going to keep repeating that, but when I did my stats, when I went into calc, regression, linear regression, up came my linear regression screen. And my values of A and B are the most important ones. So we can then, let's just keep those on the screen, say that my equation, which is shown here, is lifespan, not y equals. Lifespan is equal to 54.28, which is 54.28, plus 5.594, that should really be, times log of GDP. Now actually, I'm going to go back here because much of what I've done here is interesting because the question said correct to 3 significant figures. Variables lifespan and GDP should be correct to 3 significant figures. And that, ladies and gentlemen, is not correct to 3 significant figures. So that should really be 54.3 plus 5.59 times the log of GDP. Make sure I should check that stuff. The question went on to say, well, okay, and using that information, let's scroll down a little bit, answer the last part of the question with a GDP of $20,000. Well, we knew what the equation was. We had it there. Lifespan is equal to, it wants us to find the lifespan. It's given me the GDP. And so I need to make sure that I type that in. Now, a lot of people say, how do you type in log again? My advice is to use this button here. It is the log base 10 button, and it does a little square there. Now, when you type that into your calculator, when you press it into calculator, your calculator says, well, okay, and it does this already, long 10 comma, and it looks for you to fill something in. It is nothing more than the calculator saying, well, I'm going to fill this bit in for you already. Can you now tell me what value you want to put here? All right, so in which situation, you can see there that I've got log, comma 10, comma 20,000, which is the value that they gave me. When I typed that into my calculator, out came a lifespan of 78.3 years. Now, as I am going to start doing on all of my questions, here we go. Here is a VCAR question that was very much relating to this. Question gives you some data. There we go. We've got a HDI and we've got children. I'm going to look at my graph. What do I notice? I notice I've got my HDI there as my EV. And I've got children there as my RV. It seems to be curving. Am I going to have to choose my own transform? Nope. Remember, in an exam situation, they're probably going to tell you what your transform is. It says it's nonlinear, and it says a log transformation is applied to the variable children. Oh, now this is a little bit outside this one because I did the log X transform, but now they're asking you to do a log Y transform. It's no different, ladies and gentlemen. I promise you it is no different from what you've got. With HDI as the explanatory variable, the equation of the least squares line fitted to the linearized data is, well, let's put the data in my calculator. Okay, so there we go. There is my data all shown. You've noted I've got HDI and child as my columns and log ch because it tells me it wants me to do a log transform for children. So what am I going to do? I'm going to go down here to calculator, go into that box there, and I'm going to type the word LOG. Oh dear me, it does not like me, this stylus, at all. Let's delete that again. Please delete. LOG. Let's open a set of brackets, and we wanted child, CHILD. Now remember, this is very different from what you label that thing on the top, right? It's a calculation your calculator wants to do. And there we go. I have my 0.8808. There are my log values. Let's close that down. Okay, so what do I want to do now? I want to do my linear regression. Yeah, so I'm going to go calc, regression. I'm going to linear regression. My X list, remember, stays as HDI, so there's HDI. My Y list, though, is going to be log child. Click on OK, and up comes the values of 1.05, 1.05122460. Whoa, what does that mean? Okay, now my calculator here has standard index form on it, which isn't a lot of use to man nor beast. So I'm going to write that value here and just give you a quick crash course on that. Minus 9.519e minus 3. Okay, so first things first, that e minus 3 basically says take the decimal point and move it 3 places to the left. Now the reason it says to the left is because of this minus sign here. Your calculator has a way of sort of trying to make very small numbers or very big numbers easier using standard form. So this minus sign here says take this decimal point and bounce it 3 to the left. Now I'm going to get this wrong on my calculator, but whichever one, because the video is reversed to what I am. So I've got minus 9.519, and I'm going to bounce it 1, 2, 3 places. There we go. So it's going to become minus 0.009519. What was my other value that I had? It was 1.051. So 1.051. So I've got the data I need. What am I looking for? Well, it's a log Y transform, and in fact it's log children. So the first thing is I can get rid of anything here that does not start with log children. That gives me 3 answers. The next thing I need to know is the values that I was given. Right, okay, so I've got a intercept of 1.1 roughly. Well, in fact, that would suggest that that's gone and that's gone. So checking here, A is the only answer that is in fact possible. Now, I don't think that all of these questions will appear in multiple choice questions because they don't. Now, this here was a 2017 paper 2 question that actually went on, and it was said eggs were laid by female moths and become caterpillars. When I look at this, it is seemingly curved. Who knows? But the question is going on to say, and I'm not going to answer this for you now. I'm going to actually do this as a separate video because I think it's important to run through these type of things. But let's just see what the question is asking us to do. The question says, do a log 10 transform. Bang that into my calculator, what comes up? And this is when the equation of the least squares is approximately that, round this value to 3 significant figures. So before we even go any further, this here doesn't even have anything to do with your calculator. It just wants that there to be rounded to 3 significant figures. Then it says perform a log 10 transformation, and what does it want? It wants you to then effectively fill in the box with the values of A and B. So far doing that's got me 3 marks, just repetitive all the time. It says the least squares line predicts that log 10 area of forest by the new year will be approximately 2.85. Using the value of 2.85, calculate the expected area of forest that will be eaten. That's just using our formula, and then give a reason why this prediction may have limited reliability. I can guarantee you the wording of that suggests that the 2.85 is going to be a value that is extrapolated, and as a result, if it's extrapolated, if it falls outside of the values of the years or whatever we've been given, then, ladies and gentlemen, it is not necessarily reliable. Okay, thank you very much. That's the end of this lesson here. Scrolling to the top, what was this lesson on? He says, trying to remind himself, the log transform. Yes, it's old age, I've forgotten already. Next video that comes up is going to be a reciprocal transformation. Thank you so much for watching. If you haven't already done so, can you subscribe? And can you let people out there know these videos exist? I've got about 6 people watching me, and most of those are my family members. Hopefully the day's good. Hopefully the video's made sense. If it has, leave me a comment. Otherwise, I look forward to seeing you next time. Take care. Bye-bye.